what is place? Okay, here we have, if you're a betting man, I do bets, but very seldom, very, very seldom. But I like to bet at the horse races when I do, but not so much betting. I go there to watch the horses. I really love to watch those horses, and they're great. They're nice. They're manicured. Okay, they're pretty, right? And if you go to the horse race, or those who do, they probably heard the word place. Okay, and here's place. You have you bet on the first horse and the second horse, whichever of the two. In other words, you bet that your horse is going to be either in first or second place, and if he comes in any of those two places, well, you win, right? It's usually a $2 bet. Okay, depending on the country. But no, that's not the place I'm going to be talking about today. I'm going to talk about another type of place. And it's a place that the Greeks talked a lot about. And like I said earlier, it's a word that has gone into disuse. Nobody talks about place today. They talk about position. They rarely talk about location. They don't use that word either. They talk about position. Mathematicians, right? Meaning the so-called scientists of today, right? They talk about position, not place. Okay, so where do we put place? Well, in our universal movie tool, right? Here's the tool. Okay, a universal movie is one frame for every location of every object in the universe, right? That's one frame. So each frame in that movie has only static concepts that you can see on the top, the yellow and blue, right? And at the bottom you have this beige and violetish region, which involves at least two frames. So the ones on the top, static concepts, they have one frame. The ones on the bottom, which are dynamic, require at least two frames to conceptualize. Where do we put place? Well, we're going to put it at the top. We think place is a static concept. Okay. The problem is that the Greeks did not put it there. Okay, not all of them at least. Some of them did, but some of them did not. And actually, I would think that most of them did not. Aristotle. So let's get into that. Let's find out what these folks did. Let's start with Plato. I could start with earlier guys, but we'll start with Plato here. And he says, matter and space are the same. Whoa, that blew my mind. What do you mean matter and space are the same? But yeah, that's how he saw this. He thought that there is no such thing as an empty place, right? He says, space is eternal and admits not of destruction and provides a home for all created things and is apprehended without the help of sense, meaning touch and see, right? But by a kind of spurious reason and is hardly real, whatever he meant by real, right? He never defined the word, so we don't know what he was talking about, what he had in his mind. But I guess he was thinking about see and touch, right? That's what people identify with real, which we, beholding as in a dream, say of all existence, that it must of necessity be in some place and occupy a space. But that what is neither in heaven nor in earth has no existence. Well, two things, the image and space, meaning an object and nothing, right? The antithesis of it, right, are different. They cannot exist one of them in the other and so be one and also two at the same time. Okay, so they cannot be, you cannot have two words and say that they're the same thing. Okay, so there's a problem there, right? All things are changing their place. I guess that's what he's referring to as motion. And things, when divided, do not cease to pass through one another. Have no idea what he meant there. And to change their place. In other words, he was talking about motion. And he saw motion as a change of place. The problem with that is that the word change already involves motion. So he's using a synonym to define motion. And therefore, it's an invalid definition. It's a circular definition. It is an irrational definition if you use the word change to define the word motion for the purposes of physics. In ordinary speech, we don't care. You can say whatever you want. Okay, then came his student. His name was Aristotle. Came a little later, okay? And this is what Ari had to say. And he said, the physicist must have a knowledge of place. Okay? You have to know what place is about, right? It's important. But he says the physicist, not the mathematician, okay? And he meant physicist. He made a distinction between physics and mathematics, as well as of the infinite. Okay, now we get into infinite, okay? And not only infinite, he's going to get into what continuity means. In other words, what does continuous mean for the purposes of physics? He's going to get into that as well. Namely, whether there is such a thing or not, and the manner of its existence and what it is, both because things which exist are somewhere. He didn't know what he said there. Things which exist are somewhere, he said, existence is object plus location. But the problem is no one ever used this definition, even him. He didn't realize what he said there. But he said it there. That is the definition of existence. Things which are somewhere. Okay? So he said it, but he said it in different words, and he never picked up on that, neither did anyone else. No one ever used this, including Aristotle. Okay, so he said it, but he didn't mean it. The non-existent is nowhere. The question, what is place, presents many difficulties. Moreover, we have inherited nothing from previous thinkers. I say the same thing. We've invented nothing. I have no shoulders to stand upon, as Newton said once. Okay? No giants. Okay, so what did, let's go first with continuous, because that's an important point in his argument. This is what Airy had to say about it. He says, nature, a principle of motion and change. And again, they equated motion with change, as we saw last week. But the important thing here is, he says, infinite is often used in definitions of what? The continuous. No. Continuous means that an object is made of a single piece. That's what continuous means in physics, for the purposes of physics. But he's talking about math. That's what he's talking about. And he said the number line, numbers are infinite, meaning one right after another. Not infinite in the sense of physicality. It's not a physical entity that he's talking about. He's talking about a concept. He's saying you can count, because that's what a number is, counting. You can count incessantly. And we cannot imagine where the end of that is. And incessant is not the same thing as infinite. Infinite is an adjective. Incessant is an adverb. For the purposes of physics, incessantly, right? How you do something. Okay? But anyways, he says, what is infinitely divisible is continuous. Absolutely not. It's the opposite. What is not infinite, what is not divisible, period, right, is continuous. Okay, but he never picked up on that. And he says, place, void, and time are necessary conditions for motion. Well, I agree with place and void, right? And really, void and place should not be there either. In a sense, they should. In a sense, they should not. Okay, because we only gauge motion with respect to objects and not with respect to space, place, or void. But for sure, we don't need time. It's the other way around. Time requires motion. Motion does not require time. Okay, and that's because of the definitions of these words for the purposes of physics. Time required is a comparison of two motions, whereas motion is two locations, as we saw last week. Two locations, where do you see time? Right? And where do you see void? Where do you see place? All you need is two locations. Only if you think that maybe place is a synonym of location, which it ain't. Okay? Location is the set of distances and not the volume that an object so-called occupies. It's not the amount of water the fish displaces in the ocean, in other words. That volume that the fish occupied, that was full of water, and now you put the fish in there and it kind of displaces all that water. That volume there, that's not the notion of location, which was the notion of place and void that they had in their minds, okay? That's what they were talking about. Okay, so here we have this fellow who criticizes me, and he says about that, he says, if what Aristotle means merely is a potential infinity, right, then a continuous thing is merely something that could be broken into parts, but isn't already. So this fellow is making a distinction. He's defending Aristotle and saying that the potential is not the same thing as the actual. That's what he's referring to here. Okay, Aristotle and the pre-Socratic atomists, right, would agree that if there is some physical thing separating two other things without a break or holes, right, that this was continuous. Okay, so listen to what he's saying right there. Aristotle would agree it is a single piece, but it is not itself atomic, because he was this fellow was comparing against the atomists like Democritus and Leucippus. Okay, they were atomists, and they say everything's made out of atoms. So we're comparing two things here. We're comparing the ideal cube that's made of a single piece against things that actually exist, which are made of atoms. And so the atomists were referring to things that exist, and these people were a little more abstract, and they were saying, you know, it's not made out of anything. It's not made out of atoms, because we have these concepts such as cube, maybe, you know, maybe that's what they had going through their minds, ideal geometric figures, and you cannot talk about an ideal geometric figure made out of little particles, for example, right? Atoms. Okay, so Aristotle would agree it is a single piece, but it is not itself atomic and could be split apart into smaller pieces, right? So we're talking about the potential here, okay? However, it isn't already composed of those smaller pieces before being broken up, as the atomists would lead you to believe. Yeah, but we got a problem here. If it can be broken up, it means it was made of pieces. Otherwise, it can't be broken up. Okay, so I tend to disagree with the gentleman. No, you cannot defend Aristotle on those grounds, because whether it's potential or actual, I think, is irrelevant. If you can break it up, it means it was already made of pieces. Otherwise, you can't break it up. The word continuous means made out of a single piece, and if it's made out of a single piece, you can't break what is made out of a single piece into pieces. Okay, and that's all I can say about that. That's my take on that. Okay. Aristotle continues, says, every physical body has a place to which it moves and rests naturally without being forced. And before that, he says, natural motion is the motion that does not require an external cause. So the way they looked at it, here we have my famous pencils, right? And the way they looked at it, they said, look, if this is standing still, right, and I let go of it, something, or it itself has this motion that does not require an external cause. And so you let go of it and it falls. And you say, well, hold it. Nothing pushed it, nothing pulled it, because I cannot see or touch that which pushed or pulled this. So I let go of this and it falls down, and I say, well, why did it fall? Well, because it's got natural motion, says Aristotle. So there's no cause. It's just what? We can't see or touch. And so there's nothing there, and so it's got natural motion, which means it just falls by gravity. That's natural motion. Okay? Okay, but it goes to a certain place, right? And then change of any kind as the actuality of a potentiality as such, as movable or as potentiality. So he talked about, you know, the potential of something that just holding, like if I hold something, has the potential gravity, potential energy, whatever you want to call it, right? And what happened? When you let go of it, that potential becomes actual, because now it goes into its motion, okay? When the buildable is fully real, whatever he means by real, nobody ever defined it, it is being built, and this is building. In other words, buildable is potential. Building, or in the process of building, well, that's actual. Okay? So he wants to distinguish those. For some reason that was important to him. I don't know. I guess it was important because they couldn't see or touch the gravity, the mediator of gravity, and so they said, well, it's got natural motion, it falls by itself. We don't know why. We throw it up in the air, it falls down. I didn't bring it down, but it came down. So they never figured that out. They were trying to figure out gravity, I guess, why this world works by black magic, right? Okay, so essentially in their minds, and not only in Aristotle, but other people as well, like Melissus and you know, some of the other Eleatics, Zeno, etc. Place, void, vacuum, and position in space were sometimes used as synonyms. Sometimes they were not. They were distinguishing place from space and from void. Like in the case of Plato, he says that place is like a physical object. There's no difference between place and matter, or space and matter. And they would think of void as a place devoid of matter. So that's the void or the vacuum. So it's like, you know, some of them believed that it was the same thing. Some of them said it's different. Okay, so this is one thing. You got to look at one of these Greeks at a time, find out what each one said. But it says motion is change of place. Okay, again, he used the word change. And locomotion there, he says, okay, and yeah, you can't use the word change because change already involves motion, so change and motion in this instance are synonyms, and you cannot define a word using a synonym. So he hasn't said anything until we know what change means, and change means motion, motion means change, so we're done. So change of place doesn't tell us anything. What do you mean by place? It says place would not have been thought of if it had not been a special kind of motion, namely that with respect to place. Yeah, you move with respect to a place or position or location. That's what he's saying. And so that's how place comes into the definition of motion. What now contains air formerly contained water. so that clearly the place or space, there you can see that he's kind of using them as synonyms, into which and out of which they passed was something different from both. Okay? So water replaced air, and then air replaced water as the water went by, and that was their notion, that something is always there in that place, in that space, in that position, right? It is impossible that what has no reference to motion or the distinction of up and down can be a place. Okay? So if it's not related to motion, you cannot talk about place. Place is only has importance with respect to motion. That's what he was saying. Okay, so here we have different notions that with which he tries to explain, Aristotle tries to explain what place is. He just gives you kind of examples there, yeah? Void is a place bereft of body. In other words, place, it has a body in it, whereas when the body leaves, it leaves a void, if void means completely empty place. I hope you can understand that, right? So he's saying place is like a placeholder where which the body occupies, okay? And, as long as the place holds the body in it, it's not a void. But once you pull the body out, you have place, and he says that's void. So now the question is whether void and place are the same without the body. Okay, and he's saying no, without the body, place becomes void. Okay? But that is what some people would say, and he's not going to argue that. He's just going to say that's what normal people would think of void as being, as a place bereft of body. Place is something distinct from bodies. Okay? Every sensible body is in place. In other words, he's talking about, again, sensible, meaning eye and hands. He's talking about see, touch. And what blew me away, he says it has three dimensions: length, breadth, and depth. So place, void, space, all these have three dimensions. And even to this day, the mathematicians talk about the three dimensions of space. So that hasn't changed in over 2,000 years. One of the problems here is that breadth and depth are not dimensions. They should never be paired with length. Length, width, and height are dimensions, and depth, breadth, and elevation are vectors. Breadth and depth have to do with motion. Length has to do with a static concept. So they never figured that out, unless the translator translated it wrong, which is something else, right? Because, again, we don't have this in Greek. We don't have the notion that Aristotle had in the back of his mind. All we have is the translation, okay? But then he goes and says, place is supposed to be something like a vessel, the vessel being a transportable place, but the vessel is no part of the thing. So you put water in a flower pot, right? You move the vessel, which in this case is the flower pot, right? But the flower pot is not part of the water that you put in there. Okay, that's what he's saying. So he's getting these notions ready so that he prepares his definition. Okay, so here we go. And he says, how could a body be carried to its own place if place was the matter or the form? If the place is in the thing, place will have a place. Okay, so if the place is inside the thing, you're carrying the place together with the thing, and before you move it, place already has a place. It's where the thing is. In other words, the position, as I call it. When water is produced from air, the place has been destroyed, for the resulting body is not in the same place. What sort of destruction then is that? So he says space must be something. Oh man, that's a big contradiction. Again, if space is something, we need to define what do you mean by something, what do you mean by space? We say that space is not something. Space is nothing, the opposite of something. That's what we say in physics, but he said space must be something. He said space is like a rock, no different. Or we could even add general relativity and say time is also like a rock, because they've turned both space and time into things. Nor is it possible for a thing to be in itself, even incidentally, for two things would at the same time in the same thing. They would both be in the same place, essentially, the same thing. Okay, so what's Ayer's summary? Okay, he says, place is what contains that of which it is the place. Place is no part of the thing. Place can be left behind by the thing and is separable. Okay, these are the notions with which he gives his introduction, and finally comes up with some kind of definition. Okay, he wants you to understand what he means by place. And he says the following, says, there are just four things of which place must be one: shape, matter, some sort of extension between boundary surfaces, and this boundary itself, if it contains no extension over and above the bulk of the body which comes to be in it. And he says he rejects the first three, and he says place necessarily is one of the four, which is left, namely the boundary of the containing body. That's what he says place is. Just as the vessel is transportable place, so place is a non-transportable vessel. That's what he's going to say. He's going to argue essentially that place is space, and space he's going to treat as a container. And he's going to say the inside wall or surface of this vessel called space, that's place. And it doesn't move. What moves are things inside this ocean. Okay, that's going to be his argument. He says, so when what is within a thing which is moved and changes its place, as a boat on a river, what contains plays the part of a vessel rather than that of place. Place, on the other hand, is rather what is motionless. So it is rather the whole river that is place, because as a whole it is motionless. Essentially, he's equating now place with space, meaning space out there, the universe. And so he's saying space is a thing. It's a container of sorts. I guess it's finite. He saw it as a finite place. I guess because he had to put the gods somewhere, out there in Mount Olympus. They said, well, they can't live in infinity. And so he makes space into this container. He says place is the inside surface of that container. That's where space stops, I guess, the place. And it's immovable. It doesn't move. What moves are the fish inside this ocean. And so he says, hence we conclude that the innermost motionless boundary of what contains is place. The container, in other words, that is place. That's his conclusion, okay? And even to this day, they have problems understanding what space is. They don't use the word place anymore. They talk about position from a mathematical point of view. Space, they use it only in the context of geometry, and also to refer to that black stuff that's between the earth and the moon, that space, whatever it is, we don't care, we don't know. And otherwise they go with position, which is what? An ordered pair or triplet or whatever. Okay, so here we have Newton's, he fortunately clarified everything for us. He says, I do not define time, space, but place and motion as being well known to all. Oh, that was so enlightening. He really illuminated the issue for us. He says he's not going to define place because we all know what it is. Great. Okay, so we can't stop at Newton, and none of the other guys of his age, like Galileo or Descartes, they didn't figure this out either. They didn't talk too much about place. Maybe mentioning it, tangentially. And so here we have today's notion, and it's very hard to find anything about place because nobody uses that word. But I found the Stack Exchange, and they discussed the difference between place and position, which is exactly the issue. Okay, that's what I wanted to get to, and I did find something there. It says the following: a couple people put their comments there. Position often refers to a specific location for which there are geographic or other coordinates. Ordered pair. GPS, global positioning system, not place system, placing system or whatever. No, it's positioning. Position in many cases involves a meaning of orientation. Like, I'm in the middle of the room facing the window, so place would be the middle of the room, and position would be facing the window, how you're oriented. That was one of the comments. And essentially, this is what I conclude from what all these mathematicians have been doing for 2,000 years, right? Position, according to math, is just an ordered pair. It's how you get there, the instructions on how to get to the treasure chest. And place is a word that's more related to physics, and it's the volume a body occupies. Okay, so it's the body itself. That's essentially my conclusion on this. And so place and position, I guess you could say, are synonyms from a physics point of view, because position is the object itself and place is the object itself. So when a fish is in the ocean, it displaces water. You put it in the ocean, suddenly it displaces water. The volume it displaced, in other words, the exact volume of the fish, that would be place and position, two synonyms. And the ocean would be space. okay, so to speak. That's the notion I'm introducing here, okay? And I'm saying that's what it is for the purposes of physics. That's why we do not use the word place or position. We have no use for those two words because it's the object itself, okay? Space we have a need for because we need to explain what that black stuff is or define it or whatever, okay? And location we have to define because it has nothing to do with space really or with void or vacuum. It's got to do with distances from all other objects. So we make that distinction there. And so here are the conclusions for place, okay? According to the Greeks, right? Place is void, vacuum, nothingness, emptiness, space. They're all essentially the same. Sometimes they're not, depending on which Greek you talk to, okay? Place is the ocean, according to Aristotle at least, meaning space, the whole shebang, okay? But at the same time, place is the volume occupied by a body in other discussions. So they go like back and forth. It's like they never get that clear. Place is the volume occupied by a body. Place is the volume of water the rubber ducky displaces. And place is the body itself. In other words, position, what we call position in physics. We have no use for position or place because it's the body itself. And the Greeks, some of them, like Plato, said place is the body because there's nothing, there's no such thing as a void. That's what they would say, okay? And, Parmenides also had that idea. So did Melissus, probably Zeno as well, that, there's no such thing as emptiness, as void. There's always something there. And they probably thought of the air. That's why air was one of the four elements. Because they said, look, I put my hand there. There's something there. Apparently it's what's going into my mouth when I breathe. So there's no such thing as emptiness. Because they couldn't see it, but they said there's something there that we can't see. That's from the gods probably, air or ether or whatever, right? And so when water comes into this region, it displaces air or it doesn't displace air, if that was the argument. But the point is, there is no such thing as emptiness. There's no such thing as void or vacuum. There's always something there, okay? So this was their notion, because they could figure out there being nothing, except when you have natural motion, when you let go of the pencil, well, this is natural motion. Nothing pushed it, nothing pulled it, but the pencil fell because it has this potential natural motion, right? And so, some of them said that place is filled with something, it's a body of some kind, and others say, no, if that were the case, then place can move. Because if it's a body, you can move it, right? Can I move the air? Well, apparently that's what the wind is, right? So you can move the air. So if place is a body of some kind, if it's the same thing as matter, then you can move place. And some have problems with that, saying, well, you're moving the location itself, the empty space that the body occupied, the void. Well, there's no void, and so they went around in circles. And so place is unmovable, right? In some instances, Parmenides and Melissus essentially argued this, that place itself is not movable, and that's why they concluded that there is no such thing as change. Okay, you cannot change, you cannot move because it's already filled. So you're not moving anything. Maybe when you move, everything moves at the same time in some kind of clockwise or universal way that things are just shifting around, but you're not really moving. You're standing in place and the whole universe is moving, so to speak. So some had these notions. Anyways, we can't figure out what place is because they did go around in circles and never figured it out. For us, it's very simple. Today in physics, we say we don't use the word place or the word position. Those are words, not so much place, but yes, position. Those are words used by mathematicians, and they're referring to the instructions, the ordered pair, triplet, quadruplet, whatever, of how to get to some place, instructions on how to get there. That's position. That's what a mathematician cares about. We don't care about position because it's a site occupied by the object itself. Have no use for that concept. What we care about is location, which has nothing to do with empty space or void or vacuum. It has to do with distances to all other objects, the set of which is location. And then we can use location to back Aristotle, who said that if it's somewhere, then it exists. And that's pretty good on his part. Unfortunately, he never realized what he said.